Okay, so this is a supplemental video for section 1.2. And what we want to do, we start doing some rules, and we want to look at a table of values that we put some stuff into values. We want to find the rule, but we also want to start looking at graphing. So this is all about trying to figure out and make sure we know how to graph things out also. So here is a table. We want to try and find a rule for this. And the rules we want to find are the explicit rules. So the rules based off of position. There's an input is an X, the output is a Y. So I need to try and find a rule that if I plug in 3, I'm going to get -1 and so forth. So the first thing we want to do is try and identify, can I identify what type of graph this is? So the first thing I usually do is I ask myself, can I find the first difference? So 7 minus 3, since these all go by ones, so this is a 4. This one would be 3 minus an 8. This is a 4. It looks like all of these are going to be plus 4. So the pattern I noticed is plus 4. Please note, if these numbers are not going by ones, then this is going to be different. Okay, so we'll have to keep that in mind for more advanced problems. But this one is all about 4. So what does this tell me? It tells me that this is going to be linear. It's a linear pattern. A linear pattern. So I haven't formalized how to find the rule straight out, but because I know it's a linear pattern, I know I want to multiply by something. I'm going to multiply by 4, and then I'm going to add or subtract another number. That's kind of how the rule is going to work. So if I start with 4, okay, and I figure this out. If I think, what am I going to be subtracting by? I got to subtract by the same thing. So maybe, I don't know. So what do you guys think? Let's look at this. Let's see. Can I find a rule here? So if I do this one, 5 times 4 is 20. Okay. 5 times 4 is 20. And what do I have to, I got to subtract to get a 7. So 20 minus what is 7? 13. Let's try the 4. What's 4 times 4? That is 16. 16 minus what gives me a 3? 13. So it looks like that's what it is, correct? So then my rule would be the out, or the Y, is 4 times the N minus 13. In a symbol, the out is the Y, the N is the X, so I can usually, and this means equals, in case you did not remember. So we can actually try and go beyond this here and see if we can write the rule this way. The Y values, the Y is, that's equals, 4 times the X minus 13. So I can write that rule that way. If you want to leave it like this, that is totally acceptable at this time. But if you can see it this way, let's learn to write it this way also, okay? If you don't worry about it. I will not dock you for not writing this properly at this time. Well, the next thing I want to be able to do is I want to see this visual. A lot of times we'll draw the visual before we find the rule to see if that will help us at all. You'll need a straight edge of some type to draw these things. We have an X and a Y, an input and an output. And usually what we do is we just draw a vertical line. And usually the grid, my grid here is pretty bad, but do the best that you can with it. You can also draw these on graph paper if you can't see it in here to draw a nice one. And then what you do is you plug in and you put a dot for these points. So the first box, and it's hard to see it here, I'm just going to mark it so you guys can see it. this is 1, 2. When you draw a graph, you want to label your axes so we know what these numbers are. I needed to go up to at least -9, so I needed to put that in there. So 1 and -9. So when you put a dot on a graph, the right or left is first, then up and down. So 1 on the X, -9 on the Y, and you put a dot. That is -1. I'm sorry, that is 1, -9. Where does 2 go? 2 goes to -5. Go to 2 on the X, go to -5 on the Y, and put a dot. So rinse and repeat that for all the points in our table. 3 goes to -1. 4 goes to +3. And 5 goes to +7. If you draw this on graph paper, it looks nice and neat. But notice, you see how the dots line up? We said this was a linear pattern, correct? So if I drew these dots and I see that they all line up, I also know that it is a linear pattern. So then I can take my straight edge or ruler and draw this line. So the line should touch all the dots, nice and pretty. An arrow on each end because it goes on forever. This is a visual representation of that equation. The dots are a visible representation of this table. The dots are the table. The line is your rule. That's what it's doing, okay? Depending on the situation, when we start talking about real world situations, like a story from the real world, sometimes we will not draw this line. We will just leave the dots. But we will talk about that in more detail later. So this is what the first part of this is about. Okay? So I have on here a bunch more. I think I have up to 8 of these. If that's the process I want to see, I want you to identify what kind of pattern it is, linear pattern. I want you to try and find a rule, whether you write it this way or you write it this way. Okay? And then I want you to graph the thing out. You can put it down here if you want. Okay? Or you can put it on graph paper. If you can't figure out a rule or determine what kind of rule it might be, why don't you draw the picture and see if it can give you insight, okay, on what kind of a graph or equation it might require. Is it linear? Is it exponential? Or is it quadratic? Sometimes you can see from the picture of the dots, okay? So this is what we're going to be doing, and this ends this video. Just repeat this for the other 8.